Hey Angel, how are you doing? Help me to understand something. I'm really wanting to know what it's value engineering. I know you know, so help me please. What is value engineering, brother?
Hey, how are you? Yes, I can help you with value engineering for sure. First of all, let's define what is value engineering. Okay, it's a systemic, organized approach used to analyze the function of a product or service to ensure that it performs as required and the purpose is that it was required at the lowest possible cost. All right. Now we can divide this value engineering in two parts. We have the value engineering that is applied during the design and development stages. We can call this one the proactive part, and then we have the value analysis, in which is applied when the product is already existing in production. We can call this one the reactive part. Okay.
Okay, now I get it. Value engineering, value analysis. I get it now. I get it now. But why isn't it important in today's world?
Why is important? Well, you want to know why this is important? You just need to understand one thing: unnecessary cost. Okay. It's used to eliminate this unnecessary cost that these costs that don't provide neither quality, neither use or life or even appearance. Not that something that the customer or wants, all right? It's important because it allows the companies to maintain or improve their margins without raising prices, which keeps them competitive in the market. This is really important. You need to understand this, and this will be really good for you to understand. Okay.
Okay, so it's like something about maximizing and minimizing, maximizing profit, minimizing cost, and you can get the same product or even a better quality. But I'm curious, who was the first one to implement this, or how was this methodology uh, found or created?
Actually, that you mentioned, this was developed by Lawrence Miles at General Electric. Actually, during the Second World War, it happened to be a material shortage, so Miles look to functional substitutes, and he discovered that there were a lot of replacements that actually perform even better and at lowest cost. So
Now that you mention, I think that I know in which part of the industry this value engineering is the most used. I guess automotive, construction, and maybe aerospace definitely.
actually, you're right. Yes, Tesla, Toyota, and Chevrolet, every big company uses value engineering because, as I mentioned earlier, they need to stay competitive and they obviously every cent matters.
Is there any like formula or something about it? Like,
Yeah, actually, the core of the value engineering value analysis, it's called the value equation. Basically, is value the is equal the function over the cost. The function is the product, what the product does. Okay. For example, this one hold liquid, right? Then the cost, the resources that is required to achieve that function. Okay. How much it costs to build this thermal, right? Then the value is increased by either improving the function or at the same time reducing the cost while maintaining the function that is to hold liquid, right? Okay, this is the formula I told you, the value equation. Value is equal to the function over the cost. Okay.
now, for example, let's say I want to do this. What are the main steps to take in order to have this value engineering real good?
Yes, we have these steps to execute. Okay, we have the information phase. We gather data, requirements and constraints. Then we have the function analysis, that we define what the product does with this verb noun first. Okay, for example, conducts current, you know what I'm saying? Then the creative phase in which we have this brainstorm of alternative ways to perform those functions. Next, we move to the evaluation phase, in which we screen the best ideas based on the feasibility and cost, okay? Then we move into the developmental phase, in which we create a detailed proposal for the chosen alternative. And finally, we move into the presentation phase. We pitch the change to the stakeholders.
For example, do I need some tools or equipment requirement to do this?
Some tools and equipment we require is the fast diagramming. It's a logic map to see how the functions relate. We have the cost worth analysis, is comparing what the function cost versus what actually worked to the user. And finally, but not least, we have the BOM. We have the bill of material.
Okay, I get it. I don't know if it's too much to ask, but can you give me a real world example of this value engineering?
And smartphone packaging, okay? Now, the function of this smartphone or smartphone packaging is a protection device and contains accessories, okay? Our initial cost is $4, right? Thick plastic, high gloss finish, multi-layer cardboard, okay? Now, we need to do our value engineering, value analysis, right? So we found the high gloss finish doesn't protect the device, it's purely aesthetic, right? That does not protect, just is aesthetic. Now, what's our alternative? We use a recycled molded pulp, okay? But this is the same quality, but with a different finish, a matte finish. Now, the result, we are reducing these $4 into $1.50. The function is the same. Remember, we protect the device. Even if the other one was glossy thing, the function is the same. Instead of being glossy, we have a matte finish, but we remain with the function. That is why I mentioned you earlier. We reduce cost, unnecessary cost, okay? And we have a bigger margin with a reduced cost, okay? That is the best way in which I can show you, or I can explain you in an easier way, the value engineering.
Now, let's say, is there any rivalry or connections between other methodologies? I don't know, I'm just curious about it.
There are some connections. There is no rivalry, but there are some, conflicts. For example, in connections, we have the Lean and the Six Sigma. Lean, eliminate waste, and Six Sigma, the reduction of variation. Okay, and then rivalries, as I mentioned, we don't have. We just have this, conflict with the total quality management, because obviously, when reducing costs, we don't want to lose quality, and we ain't looking for that. And that's why we can sometimes have this conflict with total quality management.
Okay. Nice. And is there any cost benefit when implementing this?
For example, the effort is relatively cheap to implement it because it requires intellectual labor rather than expensive machinery, okay? So it's really cheap. Then, Roy.
Oh, yes. I know Roy. He's my homie.
No. I mean, return on investment. I mean, the benefit is almost outweighs the cost, okay? Not Roy, your homie. I mean, by identifying a single component change that saves pennies across millions of units. Remember, every penny matters, every cent matters. So you find this little thing in which you can reduce and maintain the same quality as mentioned in the cases of the phone, you will have a better Roy, not your homie.
Oh, okay, return of investment. Okay, but now tell me, is there any ruling or standards for this value?
I mean, yes, there are some ruling organization and standards. For example, SAFE International, the premier global society for the advancement of the value methodology, and we also have the ASTM, is the standard practice of performance value engineering.
How you become an expert in this?
Come here. Well, you can come here. You can become an expert by a certification. SAVE International offers the CVS, that is actually the Certified Value Specialist, or the VMA, that is the Value Methodology Associate. Okay, and then also, as everything in their life is time. Time makes you an expert. VMA is relatively quick. CVS requires years of project experience, but every time you do this, you will become even a better expert. Is it worth it? Yes, of course. For industrial engineers, it's highly valuable for moving into project management or senior design roles.
How do you know this is working or is not working?
There is easy to know if it's not working, and it's usually because the team defined the function too broadly. Okay, in the example, the function of the case was it protects the phone. Okay, even though if we change something about how it looks, it still did the same thing. The function. Now, if it's not working, it's because you didn't define well the function. Okay. Now, how to know if it's working? Real easy. Track the cost reduction ratio and the function performance, and that's all. That's all you need.